All right. Good morning, and apologies for being between everybody and lunch. So I'm going to just walk you through a journey of some of the major cloud breaches that have happened, and sort of the root causes, some of the themes, and really whether or not the customer or the cloud provider was really responsible for them. So who am I? I've been doing IT since the mid-90s. Mostly Linux, Unix, so I'm very infrastructure focused, not application. Started my cloud experience about 10 years ago. Pivoted into doing cloud security about 7 years ago. I'm one of the organizers of Forward CloudSec. If you're interested in cloud security, we actually have a conference next week in Brussels. That'll be available for live stream on YouTube. Spent a lot of time building cloud security programs at media and entertainment companies. Occasionally rant on Twitter. So we're going to briefly, what is cloud, but then we're going to hit on the major cloud incidents, themes, really get into a little bit of how much are cloud providers to blame for this, and then a little bit on what we can do as practitioners and security people to make the cloud ecosystem more secure. There is a blog post that accompanies this on my website, and the slides are linked to at the end, so you don't need to take a bunch of pictures. So why is the cloud different from on-prem? Traditionally, you think about network security, you've got inside the firewall, outside the firewall. You have your network defenses, and you kind of have a very two-dimensional view of things. But when you suddenly put all of your management APIs on the public internet, you make them all authenticated by a bunch of highly random strings. You no longer just need to be looking for armies on the horizon, you need to be looking for things coming at you from sort of other dimensions. So this is where multi-cloud governance can kind of get very complex. If you spent any time in the cloud security space, you would have heard of the shared responsibility model. It basically states, cloud provider is responsible for the security of the cloud. Are there badge readers on the doors? Are there generators? Do the generators have fuel? You're responsible for what you do in the cloud. Did you install an end-of-life version of an operating system? Did you misconfigure your Apache server? Orange had some great examples of misconfiguring Apache server yesterday. All of that happens in that blue section, all of that is allegedly your responsibility. You're responsible for configuring the cloud correctly. And that's sort of the liability shield that a lot of companies that are much, much larger than you are leveraging. So now we'll get into a few breaches. All of these are really documented on a website I created called breaches.cloud. There's a lot more examples, but we only have 30 minutes, so I picked some of the best. We'll start with the oldest one. Year is 2014. In cloud years, that's about 80 years ago. CodeSpaces was an SVN repository hosting company. The attacker managed to gain credentials to, quote, the Amazon EC2 control panel. This was so long ago that the AWS console wasn't even the same. They got access, and they tried to extort the company. When the company didn't buy their extortion attempts, they deleted everything. They deleted all the backups, all the production servers, all of the data that was sitting in AWS S3. CodeSpaces never recovered from this attack. They also never contacted AWS support during this incident. This is really the first moment where everybody realized, oh, we need to move to this concept of a multi-account strategy. Because when you have all of your eggs in one little billing bucket, and that billing bucket gets deleted, there was no protection, no additional authentication, no offsite backups. We actually saw this almost exact same issue play out over the summer. An Australian pension fund named UniSuper was hosting their stuff in Google Cloud Platform. In this case, Google Cloud Platform was kind of the threat actor. They went and were doing some beta software and whatever, but they had a time window where the software would shut down after a certain period of time. And when that happened, it deleted all of the online backups for this company. So for about a week, nobody knew where the $12 billion worth of Australian pension money was and who it belonged to. Luckily, UniSuper had off-site, off-cloud backups that they were able to restore from. Fast forward a little bit more. September 2018, former Cisco engineer deletes 456 virtual machines that run WebEx. That occurred 5 months after he was no longer employed by Cisco. He was identified by law enforcement by his IP address. Not the credentials he was using to delete these machines, but by his IP address. There was never any motive determined for this. Kind of leads me to believe that this was potentially an unfortunate accident. Engineer was in a system. He was like, oh yeah, I need to clean this up. Runs Terraform destroy. Suddenly he's looking at the logs and it's like, oh no. So Cisco prosecuted him. He was on a work visa. Maybe there was some, they thought they could cover up their mistakes. Because really, what we know from this is Cisco was using shared credentials. Those shared credentials weren't rotated when the engineer left the company. And to some extent, he was forced to use a system that wasn't a company system to get his job done. So 2022, LastPass. This was actually 2 incidents that culminated into a major issue. So now we actually have every password manager on stage this morning. So LastPass suffers 2 security incidents. The first one was a very targeted one related to malware. That got them access to the LastPass GitHub repository. Once they had access to the source code, they were able to kind of figure out, okay, who are the right people, who are the whales, for lack of a better term, in the company. And they identified one. So the second breach started with a senior DevOps engineer's home Plex server that had a vulnerability on it. So a threat actor managed to figure out, hey, I know who this person is. I know they have a Plex server. I'm going to get onto the Plex server, and then I'm going to pivot to their personal machine, which also happened to have the decryption keys needed to access the AWS LastPass production backups, end quote. AWS LastPass kept all of their key vaults on-prem in a data center. They only used AWS for backups. But once that DevOps engineer's keys were out, they were able to get access to the backups and decrypt the backups. Now, typically, AWS encryption is done with KMS, and with KMS, the keys never actually leave the data center. You can't get the decryption keys. You can only use the keys to decrypt the data and get the raw data. The fact that the threat actor got decryption keys for the backups tells us that they were pre-encrypting that, so good for them. Unfortunately, they were in a LastPass backup vault that a threat actor managed to get access to. No one's ever been implicated in this incident, but everybody who's researched it is pretty sure it's some kind of nation-state threat actor. Okay, Capital One. So Capital One was one of the biggest cloud breaches to date, perhaps until Snowflake, which we'll get to in a minute. The perpetrator was a, quote, former AWS engineer, which really had absolutely nothing to do with the attack, but the media always likes to say that because it makes for scarier headlines. So she discovers some kind of server-side request forgery, proxy bypass on an exposed Capital One web server. take the proxy bypass, use that to access the instance metadata service. Get credentials from the instance metadata service, use them from her home machine. Actually, it was a bunch of VPN machines she had to look at all the S3 buckets. Congratulations, profit. Or not in her case, because she mostly just collected the data and didn't do anything with it. But that data was financial information on 100 million people. So this whole idea of an SSRF or proxy bypass with the instance metadata service has been around for a long time. First known real case of that was a Prezi responsible disclosure that happened in October 2014. But even prior to that, in 2013, Google implemented a mitigation for metadata access proxy bypass issues. 2017, Azure implemented the same. 2018, we were getting a little bit more like, come on, AWS, why aren't you doing this? So what is the instance metadata service? It's a link local address. And it's how the instance itself knows all of the things that it needs to know about the environment that it's sitting in, what its MAC addresses are, what its bootstrap script should look like. But within AWS, one of the things you can get out of that are AWS credentials, very random strings that you can use to attack the control plane by just curling the link local address. And so this example here, basically I'm saying, hey, tell me what role I have. And then with the answer to that, I say, oh, go give me the credentials for the role that I have. There's no way to manage access to this through security groups. It's a link local address. It's managed by the kernel. It's not managed by AWS. So now we get to actually where Stockholm and me kind of collide in this Capital One story. December of 2018, Amazon opens the EU North region here in Stockholm. And it was enabled in all customer accounts. Customers didn't have the option to say, I don't need to be in Stockholm. Let me turn that set of data off. So, as I do, I keep track of what's going on in AWS. I was like, oh, new region. I better go enable all my detection and prevention capabilities in this new region. Except I couldn't, because the Two Pizza team that was launching the Stockholm region hadn't scheduled with the Two Pizza team that managed guard duty to get that service deployed and ready to go when the region launched. So I had a major gap in EU North 1 in my telemetry. Come January, I get a little bit more snarky. March. So from the indictment, we know the attacker finds a misconfigured WAF and gains access to credentials. She then leverages the EU North 1 endpoints to bypass the detections that guard duty would give Capital One and her other victims the ability to say, hey, there are credentials that should only be used inside of AWS that are now coming from these NordVPN or IP Predator VPN nodes. You should go and do something about that. But because guard duty wasn't available here in Stockholm, nobody knew the data access was happening. We don't know much about the WAF. I'm not even entirely sure that it really was a WAF. That was just the name of the IAM role that was used and what was available to us, OSINTing what happened from the indictments. But what we do know is that it had significant permissions to access Amazon S3. All right, so in May, guard duty finally becomes available in Stockholm. July, the indictments are issued. But now the finger pointing begins. Because 100 million people's credit card records are on the internet, United States Senate gets involved. And they explicitly go out to AWS and say, hey, was an SSRF actually used here? How many other incidents used SSRF to compromise the metadata service? how is AWS warning its customers about the potential threat of somebody using an SSRF to gain credentials and exfiltrate them and pull them out of the environment? And also, hey, so we know that Netflix brought this up, or at least a senior engineer at Netflix brought this up and said, hey, we need a solution to this problem. So what was your response to that? So that was the question to AWS. CISO responds about a week or so later. They completely hid behind shared responsibility. They blamed the breach 100% on Capital One. They denied other incidents involving instance metadata credential exfiltration based on SSRFs. Further in there, they actually said, oh yes, well we tell our customers and we give them a whole bunch of services like AWS Guard Duty, and they can use that to protect themselves against these sorts of things. Except of course they couldn't, because we were here and there was no Guard Duty here. So Amazon opened this region, EU North 1, exposed all AWS customers and didn't give them the ability to mitigate the threat. And then they kind of threw their AWS, or they had Netflix throw their own engineer under the bus, saying, yeah, we don't know about this request. I think the actual request happened on Twitter. But we have no problems at all with AWS. So November of that year, right before reInvent, AWS introduced the Metadata v2 service. 113 days later. Metadata v2 actually does the same thing that Google and Azure did, which is basically you have to go and get a token and pass that token as part of a header if you are going to call the metadata service. And that really bypasses a bunch of proxy bypass and server-side request forgery issues. Doesn't necessarily protect you from remote code execution. So if you can get on a box, you can use the same curl commands I had 3 slides back and get credentials and then use them outside of AWS. Luckily, Guard Duty is now enabled every place, and you'll get detections if you've set that up. Finally, in this one, September of 2022, $190 million class action lawsuit settled. So fast forward 2 years. June of 2021, Mandiant identified a threat actor known as UNC 2903. They were pretty much attempting to do the same thing. Uncategorized threat actor scanning AWS IPs, looking for Adminer, which is an open source vulnerability management tool. The specific version was vulnerable to this CVE that had an SSRF. So, like you see here, they point the login page to a little Python script that's returning a 301 redirect. That 301 redirect redirects to the link local address and says, hey, give me your creds. And it happily comes back as an error because adminer doesn't know what to do with a bunch of JSON. I like to use this example as the initial access method when I teach my AWS incident response class, because it is a really common pattern. You've got a thing on the internet that's exposed to the world. That thing has a CVE. Maybe it didn't have a CVE when you put it on the internet, but it does now. That CVE is exploited to get credentials. Credentials have too much access. Chaos ensues. And again, exactly the same pattern as what we saw with Capital One. So speaking of chaos, major doozy here from Microsoft. And this is a failure of Microsoft as a cloud provider. The next example will be as a failure as a cloud customer. So Storm 558, attributed to the PRC, somehow obtained a consumer Microsoft services account signing key. So this is what I would use to log into Minecraft, what I would use to log into Xbox, my personal Outlook accounts. But Chinese government was able to use it against enterprise production tenants. In this case, the United States State Department. Now, 558 isn't a new player. They were linked to Gmail compromises in 2009. They were linked to the issue when all of our RSA key fobs had their seeds stolen in 2013. That one isn't a cloud incident, but the RSA is an awesome incident response story and is highly dramatic. So how did they discover this? Well, Microsoft didn't discover it. In a rare good use of American tax dollars, State Department bought the top-tier Microsoft licensing, which gave them the logs they needed. Then they wrote something called Big Yellow Taxi. And Big Yellow Taxi was looking for the mail items accessed call from a token that was not actually issued by their tenant. That allowed them to see, we have some very VIP mailboxes that are being accessed, not by those VIPs. What's going on here? So they notify Microsoft. Microsoft says, these accesses are all signed by a consumer key. That's odd. So this was all investigated by the US Cyber Safety Review Board, which basically the only nice thing they had to say about Microsoft is that Microsoft completely cooperated with the review. Otherwise, they called out Microsoft for being completely abject in their cultural and technical risk management and deprioritizing security over features and usability. This report is also great because it's the first time we've actually seen US regulators calling out all of the cloud providers to do a better job on securing their infrastructure and helping us secure our infrastructure. And then you have a consumer key that's used for Microsoft, for Minecraft and stuff that was issued in 2016 that's being used by foreign governments in 2021 or 2023. Kind of what's going on there? Well, apparently when they tried to actually rotate this key, they caused an outage in Consumer Outlook. And so since then, they stopped rotating the key. So yes, keys that my kid uses to authenticate to Minecraft are now valid against enterprise and government customers and had been forever. So literally, while Microsoft was cleaning up the mess and responding to requests from the National Cyber Safety Review Board, Russia was getting involved. So this threat actor managed to compromise, quote, a legacy non-production test tenant account, as they worded it. And from there, they were able to pivot into Microsoft's main corporate tenant. The threat actor was Midnight Blizzard, also known as Cozy Bear, hence my picture, attributed to Russia's SVR. Their initial goal, as stated by Microsoft, was all the internal Microsoft communications about Midnight Blizzard. So, most narcissistic threat actor ever, I guess. So this is an example of a cloud provider actually acting as their own negligent customer. The initial access was the compromise of a test account. We'd expect MFA to be on all production accounts, but if I'm a user and I'm just learning how to write Terraform and creating new users in a Microsoft tenant, okay, yeah, I'm going to create a user. Then I'm going to forget to delete the user. I'm going to create another user. Mandiant flagged APT29, the Cozy Bear, as leveraging self-enrollment abuse as one of its techniques. So when you first sign up and get an enterprise Microsoft account, you have a password, and your corporate IT desk mails you the password, and you're prompted, okay, go log in and set up your MFA. So what do our healthcare data, mortgage applications, call records, and how much we're all willing to pay for Taylor Swift tickets have in common? Well, they were all stored in Snowflake, and now they're all available on the dark web because the companies that were collecting all of that data and securing it were victims of info stealers. Now, the question should be, how is it that highly sensitive personal data was exfiltrated by just using a compromised password? That's because none of these customers had MFA enforced on their accounts. Snowflake engaged Mandiant to ensure that they were not compromised. Mandiant confirmed there was no compromise of Snowflake itself. Instead, Mandiant found that all of these customers did not require multi-factor authentication, and in many cases, the credentials had not been rotated for as long as 4 years. So yes, in the summer of 2024, we still have massive data breaches due to lack of MFA. So basic themes come out of all of this. Cisco didn't invest in proper onboarding and offboarding of their contractors. CodeSpace didn't invest in offsite backups. Microsoft didn't invest in auditing its enterprise applications that had access to test and production tenants. The victim of UNC 2903 didn't invest in enabling IMDS-v2. But the other set of themes here are the cloud providers. AWS didn't secure its metadata service, because if it had, even though they would have found a vulnerability in Capital One, they would not have been able to get the credentials out. Snowflake didn't enforce MFA on its enterprise customers, nor did they give customer security teams the ability to enforce MFA on their own accounts. And then Microsoft was just grossly negligent in the case of Storm 558. So this past spring, Rich Mogul and I, we came up with a universal cloud threat model. It's not threat model in the same spirit as Dread and Stride, but rather it's a way to think about your whole cloud infrastructure and what kind of threats you're likely to face. 90% of organizations will have 90% of the same problems because we're all on the same internet. So that's the core of this threat model, and it applies to more than just cloud. The key piece of this are the attack vectors. They're universal against almost all the incidents we've seen. So lost or stolen credentials, we saw that with WebEx, we saw that with CodeSpaces, we saw that with LastPass and Snowflake. Publicly exposed resources is pretty much every time you've seen a S3 bucket negligence award issued. Creds exposed by application security flaws, that was the case in Capital One. Unpatched vulnerabilities was the case in the UNC 2903 case. This slide is from the past summer. So AWS has a customer incident response team. Highly recommend, if you ever find yourself in an AWS incident, open a support case and ask for the cert. They're a free service. You don't need to be an enterprise customer. That's most of the sales pitches you'll get from me today. Of all the incidents that they have addressed, 66% of them have involved IAM access key credentials being mishandled. So get rid of your long-term access keys. The additional 13% now are things that are exposed on the internet, like that case of UNC 2903. Are the cloud providers to blame? Yeah. So Amazon says security is job zero, but really, kind of, whose security are we talking about? Are we talking about that of Amazon or the customer? It's clearly not job zero to have core security controls enabled as part of a regional launch prerequisite. That they'll wait 95 days for. It's not job zero to ensure that data and metadata actions are easily delineated. It's not job zero to ensure that all authenticated actions are logged and that those logs are available to us for free or not behind a very high paywall. It's not job zero to ensure that their software is compatible with their new security features. After Metadata Service v2 came out, it took a number of years before things like CloudWatch logs supported it. It's not job zero to provide free and useful cloud security posture monitoring. So yes, I would say security is job zero for AWS, but it's not the technical security of their platform or of their customers. Job zero is protecting the security of AWS's primary position among the top hyperscale cloud providers. What that means is it's time for us to demand more of our cloud providers. They need to make it easier for us to do our side of shared responsibility. They need to have clearer documentation. They need to have secure defaults. If I'm going up and spinning an instance right now on AWS, the console is going to let me open up 3389 or port 22 to the world. That's not acceptable. Because if they don't fix things, then we need to step in and ask our governments to do it. Because at this point, cloud security is becoming way too dangerous. We have folks who have the equivalent of a 16-year-old with a driver's license being given one of the most complex technical creations of modern IT and being told, try not to crash the plane. And with that, perfect timing, blog post, thebreaches.cloud, how to get in touch with me. It's lunchtime, so if you want to ask me questions, you can. Otherwise...
Yeah, thank you very much. A big round of applause.